ASDIP Concrete includes the design of two-way slab systems. But how do you actually design a two-way slab system using ASDIP Concrete? How do you model the structure? How do you check the results? How do you optimize the design? This is Javier Encinas, and today we're going to design completely from scratch an example of a beam-supported two-way slab system. Let's get started. As an example, consider this beam-supported two-way slab, which is part of a multi-story office building. The system has 6 spans in X. The span length is 25 feet, and 4 spans in Y. The span length is 23.6. So the goal is to model this structure in ASDIP Concrete, find the reinforcement for bending and shear for both the slab and the beams, and check also the slab thickness. The initial preliminary dimensions is that the slab thickness is 7 inches, the column size is 24 by 24, and the beam size is 28 inches wide by 24 inches deep. F'C is 4 ksi and Fy is 60 ksi. Let's model this in ASDIP Concrete. Let's go there. And this is the project manager in ASDIP Concrete. Here you can see the modules included in the package: concrete columns, concrete beams, concrete or masonry bearing walls, one-way slabs, concrete shear walls, and two-way slabs. In this case, we're going to design a two-way slab. I have created an example already. It's shown as a node in this tree. Double-click on the node. And this is a template of a two-way slab design in ASDIP Concrete. In this example, this is a two-way slab beam supported. So we need to specify the dimensions of the different elements. This information was given in the statement of the example. The slab thickness is 7 inches, the beam width is 28 inches, and the beam height is 24 inches. The spans can be modeled as 5 spans in X and 4 spans in Y. The span length is 25 feet in X and 23.5 in Y. So this is the geometric information of the system. If we go to the materials tab, here we specify the material properties. The concrete F'C is 4 ksi, also given in the statement of the problem. And we're going to use the Whitney stress-strain distribution. For the reinforcing steel, the rebar yield strength is 60 ksi, and we're going to use the elastoplastic stress-strain relationship. We go to the loads tab. In this case, we're going to use a nominal set of load cases, and we will ask ASDIP to combine them per the ASCE 722 load combinations. This checkbox is checked. That means that ASDIP will calculate the slab cell weight internally, and we are specifying a superimposed dead load of 10 psf and a live load of 65 psf. It's a uniform load all over the place. With this information, the program can calculate the moments along the system in a typical design strip, both in X and in Y. Here in at a glance, we can see a summary of the results, the moments in the column strip and the middle strip for an exterior span and for an interior span. So these are the acting moments, MU, and these are the capacity moments, so it's phi-mn. And this is the ratio between both. In this case, the ratios are less than 1.0, so everything is passing. The same applies for the middle strip. So these numbers apply for the slab in X, and these numbers apply for the slab in Y. At the bottom, we can see the beam design. Here at the top is bending design, and at the bottom is the shear design. Here are the acting moments along the beams, the capacity moments, phi-mn, and these are the ratios. Or the ratios are less than 1.0, everything is passing. This applies for X, this applies for Y. Here at the bottom, the design ratios. The direct design method limitations, that we're going to see that in a moment, is passing. Also, the minimum slab thickness ratio is 0.94. Let's go to the condensed tab. This shows the results in more detail. They are grouped by topic. This is in tabular form. Here we can see the on-factor loads. the calculation of the slab self-weight, 87.5 psf, and the controlling load combination is 1.2 dead plus 1.6 life as expected. Here's the calculation of the bending moments along the X strip. It's the total moments, then the total is divided in column strip and middle strip. In the column strip, the total moments are divided in the moments resisted by the beam and the moments resisted by slab. This applies for X and this applies for Y. If we go to the reinforcement tab, here we can design the rebars in the slab and in the beams. Here there are some controls that have been designed in such a way to simplify this process. For example, for the slab X bars, top bars and bottom bars, here we can specify easily the rebar size and here the spacing. And then the distance D prime, which is defined as the clear cover plus the bar diameter over 2. The same applies for the middle strip, and all this applies also for the rebars in the Y direction. For beams, here you can specify the top bars, here the number of bars and the bar size, and the location of bars to D prime. The same applies for the bottom bars, and here the design of the stirrups. Here you specify the number of legs per stirrup, here the number of stirrups, then the bar size, and then the spacing of the stirrups at the left end and at the right end. If we go back to the condensed tab, here are the calculation of the slab reinforcement in X for the end span and the interior span, column strip and middle strip. Here are the bending moments. This is a required area of steel, which is less than the provided area of steel. So everything is passing in this case. The same applies for the slab in the Y direction. And here is the calculation of the bending moments in the beams in the X direction for the different spans, end span and interior spans, and the location. Here are the bending moments at these locations, the required area of steel, which is less than the provided area of steel. Everything is passing. And here is the design of the beams in X for shear. This is a required steel area over spacing, which is less than the provided steel area over spacing. So everything is passing. The same applies for the beams in Y, in bending, and the beams in Y in shear. If we go to the detail tab, this is a more detailed set of calculation, step by step. Here are the limitations check of the direct design method. The number 1, there must be 3 or more continuous span in each direction. We are complying with that. The number 2, the span lengths must not differ by more than 1/3 of the longest span. We are complying with that. The number 3, the panels must be rectangular with an aspect ratio not exceeding 2.0. We are complying with that as well. Number 4, column offset must be not exceed 10% of the span in the direction of the offset. We don't have any offset in this case, so we are complying with that. And the number 5, the on-factor live load must not exceed 2 times the on-factor dead load. We are complying with that as well. These are the material properties. These are the calculation of the slab thickness check. Please note that in this case, the slab is supported by beams, so the punching shear is not critical in this example. So we are checking the slab thickness for serviceability requirements. This is the calculation of the slab thickness required, which is 6.6 inches. We are providing 7 inches, which is okay. This is the calculation of the bending moments in the X strip, the calculation of the bending moments in the Y strip, and this is the calculation of the reinforcement for a slab in the X strip. This is the calculation of the reinforcement for the slab in the Y strip. This is the calculation of the bending design of the beam in the X direction. And here is the design of the beam for shear. In this section, the program checks all the stirrups according to the ACI code. These are the references. Please note that in this example, the beam width is 28 inches, so we need 3 legs of stirrups to comply with the code. Finally, we go to the graph tab. The program generates this image, which is the framing plan, showing the exterior span and the first interior span in each direction. The image shows the rebar that we just designed, Let's go back to at a glance. As you can see, it's very easy to design a two-way slab system using ASDIP Concrete. With this, we conclude the presentation of this example of a beam-supported two-way slab. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.